The way data get stored in a blockchain is that they get stored in a ledger, and then the ledger gets encrypted by a function called hash in a block, and then blocks get chained together. Hello everyone, I'm Amir, and on the second episode of Career Podcast, I'm going to talk about what is blockchain. On Career Podcast, I'll talk about everything that I learned through my career path. So these things that I'm explaining about, I'm not expert or professional in any of them. So if you want to use this data in anywhere, do your research and don't depend on my explanations totally. The second thing I want to mention before I start this episode is that English is my second language and I'm not a native speaker. So there's going to be some bloopers. So I just want to mention that. Now let's jump into this episode's topic, which is what is blockchain? It may get really vague or complicated, but I really try my best to explain it simple. And when I was really studying these kind of topics, there were two problems, which was, it was a lot of information, but all of them pointed out to one specific thing in blockchain, or the data was too vague, too complicated. I didn't know what was happening. So let's jump into it. What is blockchain? Now, first, we need to know what is blockchain in nature. Now, blockchain in nature is a way of storing data. It's like databases, but decentralized and distributed. So when we had databases, what was happening was that data was getting stored in one place. So if we needed to access the data, we should have had a request and the server would have sent us the data. But what's happening with blockchain is that everyone has a copy of a data and it's getting updated constantly. So blockchain in its nature is a way of storing data, it's a system. But the way we use it, because we have computers, we use it as a code. So we use the system, a way of storing data. We made codes out of it. We translated it to code language so computers can communicate with it. So we can, use it in modern world. So blockchain in its nature is a way, but it's a code. So it can be written in various programming languages like Python or other languages. So blockchain is a code and a way. Now blockchain works on a network of computers. If the network gets really big, we call it internet. So blockchain works on a network of computers called internet. Blockchain works on internet, and Bitcoin works on blockchain. Internet, blockchain, Bitcoin. So Bitcoin is not blockchain. Bitcoin uses blockchain to work. So blockchain, when did it get first introduced or invented? Actually, blockchain got introduced with Bitcoin. In 2008, an anonymous guy that we don't even know if it was one guy or a group called Satoshi Nakamoto, introduced a new digital currency called Bitcoin. And in that introduction, he said that I use blockchain to run Bitcoin. Now, before Bitcoin was getting introduced, there were a lot of attempts to make a digital currency. But one big issue, there was other issues also, but one big issue was double spending. How should we deny people who want to copy paste the digital currency? Because in real world, you cannot go and print out money for yourself. But in digital world, it's really easy to copy paste digital currency. But blockchain and cryptography really helped Bitcoin to function, and Bitcoin was born, and now you're using it. Now I'm gonna explain what happens when you trade Bitcoin and how blockchain functions. But because it's really gonna be so complicated, I'm gonna may have a summary in the beginning and have a summary at the end. So I'm gonna have two summaries, one in the beginning, one at the end, two simplified versions, and then I'm gonna explain what happens when you buy and transfer Bitcoin. The way data get stored in a blockchain is that they get stored in a ledger, and then the ledger gets encrypted by a function called hash in a block, and then blocks get chained together. So if someone wants to change one data in the middle of a blockchain, it gets impossible because they're chained and encrypted together. So if you change one block, others get affected too. So it's really secure. And Bitcoin runs on blockchain. So when you transfer Bitcoin, you're actually using a blockchain. So you buy a Bitcoin, you have your key, you sign it with your digital signature. So you prove that it was you that owned those Bitcoins. So you're robbing them. Then you send it to a network. Network then works to prove that or to validate it if it was you, or if your transaction was actually true. Then it gets validated, it gets proved, and then after it gets validated, it adds to a new block and adds to the blockchain, and your transaction actually works. That was a simplified version. And let's go to what if I really want to go onto the internet and buy and exchange some blockchains, some Bitcoins. Okay, so first I go to a Bitcoin provider or any digital currency provider, like blockchain.com or Bitcoin official website, bitcoin.org. I go to blockchain.com and I buy a wallet. All right, so we said that all computers in a blockchain network have access to all the data. But the question for me was, if I have access to all the data, why it's not taking any storage in my computer? Computers all in a blockchain network are called nodes, and everyone is not a full node. A full node is someone who has downloaded all the data into his computer and has a good internet and constantly updating the blockchain. We are not full nodes. We just go to blockchain.com Explorer, and it's like they are showing us from their full node, from their blockchain data. So we don't have all the data they have, and they're basically showing us. I go to blockchain.com and I make a wallet. And then when I make a wallet, I basically generate an address. The address is a function called helps me to have a function called digital signature, with providing me two keys, a secret key and a public key. The public key is basically my address. Everyone has it. But my secret key, I should keep it and use it to provide my signature. The way signature works is really complicated. You guys can Google it. It's called ECDSA and Math Trapdoor. They are the functions that help digital signature work. But I use my secret key and I combine it with the message, that is a transaction, and I end up having a signature. When I want to send a Bitcoin, I use the signature and the message, and I send it to the network, and then the network can use my public key and the signature to prove if it was the owner of the secret key, me, who sent those signature, send those Bitcoins. Okay, now we know what valid is and what secret key and public key is. Let's see. Guess that. Let's imagine I want to buy a few Bitcoins and transfer it to someone else. So I go to someone who already has a Bitcoin, and I buy some from them. Now that I have a Bitcoin, I want to exchange it and I want to transfer it to someone else. I want to transfer it to my uncle. I should get a reference, put a reference to other transaction that is showing that I already have those Bitcoins. It's called transaction chain, and it's different from blockchain. Transaction chain is you should reference your transactions that are showing that people in the past actually transferred some Bitcoins to you to show that you have the Bitcoins to spend them. This way, they prevent double spending, because when you input a transaction, when you reference a transaction as your input, it means, look, I used to have these Bitcoins, now I want to spend them as an input. You can no longer use them as input again, so you cannot double spend those Bitcoins. You have a Bitcoin, you sign it with your private key, then you have a Bitcoin, you put inputs, other previous transactions to say that you have those Bitcoins. Then you sign it, and then you send it to the network. In the network, it doesn't go instantly. True, and it doesn't go instantly to the blocks. First, it goes to memory pool. It's called mempool, short form of memory pool, of all the nodes. And then it's waiting to get approved to join a blockchain, and your transaction gets approved. But who approves that these transactions are true? They're called miners, and miners provide security to blockchain network by providing that transactions are true or false, and they get rewarded for getting the network secure. How do they do it? How do they secure the network? So imagine that my transaction is on a mempool and it's waiting to get approved, and everyone can make a block and include my transaction in it. So if that would be the case, everyone could do fraud. Everyone could do fraud, and someone could say, I gave him too many Bitcoins without me approving it, because everyone can make a block. But everyone can make a block if they find an answer to a math problem. Okay? So miners solve math problems. With solving math problems, randomly, one of them who finds the math problem before the others gets to approve a block and add it to the blockchain. And they get rewarded, and the reward actually halves, and it's called halving, every 210,000 blocks. So they're saying after 2140, the number of Bitcoins produced is going to end, and we're going to have 21 million Bitcoins, and it's going to end. So this way the value of Bitcoin balances. So they the miners approve your transaction by actually solving a math problem. They add it to the blockchain, and then it gets approved. And your transaction actually gets approved, and the Bitcoin is transferred. But what if someone has too many miners and can make more blocks? And because the way that the blockchain works is that the longer blockchain gets approved. So let's say two people at the same time find a math problem. Two blocks are approved to the blockchain until the next block is found on top of one of them. And then the longest the longest version of blockchain gets approved and the others fail and go back to the mempool. Let's say someone has a lot of miners, which is like hash power. Let's say someone has a lot of hash power and can make longer blocks. That's actually really impossible because he is like fighting a whole network, and there's a saying that you have to have at least 50% of hash power of the network to have 50% chance of winning those battles of finding math problems. The last thing that I want to mention is how chaining, and it's called hash, how hash works. The hash function that is used to chain the blocks works like this. It has a free variety of input. You can give it free variety of input, but the length of output is always the same. So if you give it a number, the output length would be 12. If you give it a book, it would be 12 too. That's the first feature. Second feature is if you change the input a little bit, even a little bit, the output is going to totally change randomly. And the third function of hash is you cannot guess the input by having the output. So I cannot give you a hash and you can say, oh, this is the book that you hashed it and turned it to this. You cannot guess it. So it's one way. The data when wants to go into a blockchain, it goes as a ledger of list of transactions, and then it gets hashed as a number. The hash goes into the next block. So I have a block, there's a lot of data in it, I hash it, I put the hash at the top of it, and I put the block's hash onto the next block hash. So the previous block's hash is the input of one of the inputs of the next block. So let's say I want to change a data in the middle of a blockchain. If I change it a little bit, let's say I change it so someone gave me $2 million, 2 million Bitcoins. If I change it a little bit, the hash would change and all the blocks would get changed because they're chained together, previous to the next, previous to the next. Everyone has a copy. They're gonna know that it was me who changed it, and they're not letting me to do that. Now, let's say, what's the use? If you actually think about it, we are transferring, and that transfer and that history keeping is giving us trust, and it's actually cutting out the middleman, too many features, low fees, low transaction fees actually, and the applications can be too many things like voting. We are right now transferring Bitcoins, money, but let's say that transfer is a vote. You can actually know who you're voting to, and everybody can know who you're voting to, and you're making sure that your vote has been applied. Actually, there's a video called Trust Gap, is a TEDx. It's really cool about what Bitcoin and what blockchain is helping us with. You can actually go watch that. But blockchain, what is really helping us with is the trust, and is cutting out the middleman and is getting to do transactions instantly and without needing someone else to approve it. So that's how blockchain works. A number of blocks getting chained by hash. You cannot change the middle of a block. You cannot change the data after it's getting stored in a blockchain. In Bitcoin, you have wallet, you have two keys, secret key, private key. When you want to exchange, when you want to transfer Bitcoin, you need to reference it. It's called transaction chain. and you have to reference to show that you have the Bitcoins to spend them. And after you input a reference, you cannot input it for the second time and double spend. You cannot do that. After you do this, your transaction goes to the mempool. It awaits for getting approved. Miners solve a math problem to approve your transaction and include it to the new blockchain as a block. And everyone who finds it gets rewarded by Bitcoin. That's how it's getting done. That's how it works, and that's how blockchain and Bitcoin work together. All right, it's finished. Actually, this episode was really difficult for me. So thank you guys. I am doing this just to make sure it was a clear explanation. So thanks for watching me. If you think this was helpful for someone else, send it to them. That's the way you can help me. That was the second episode of Career Podcast, and I'm Amir. Thanks for watching. Blockchain, second episode, Amir. Thanks.